Scientists discover secret symmetries that protect our Earth from the chaos of space. Can this be a coincidence or God's planning? A new analysis of chaos in the solar system reveals how planetary collisions are avoided over billions of years. Earth probably should not exist. That's because the orbits of the inner solar system planets, Mercury, Venus, Earth, and Mars, are chaotic, and models have suggested that these inner planets should have crashed into each other by now, and yet that has not happened. Newly research published May 3rd in the journal Physical Review X may finally explain why. Through a deep plunge into the models of planetary motions, the researchers discovered that the motions of the inner planets are constrained by certain parameters that act as a tether that inhibits the system's chaos. Besides providing a mathematical explanation for the apparent harmony in our solar system, the new study's insights may help scientists understand the trajectories of exoplanets surrounding other stars. Unpredictable planets. Planets consistently exert a mutual gravitational pull on each other, and these little tugs constantly make minor adjustments to the planet's orbits. The outer planets, which are much larger, are more resistant to little tugs and so maintain comparatively stable orbits. The problem of inner planet trajectories, however, is still too complicated to solve exactly. In the late 19th century, mathematician Henri Poincaré proved that it's mathematically impossible to solve the equations governing the motion for three or more interacting objects, often known as the three-body problem. As a result, uncertainties in the details of the planet's starting positions and velocities balloon over time. In other words, it's possible to take two scenarios in which the distances between Mercury, Venus, Mars, and Earth differ only by the slightest amount, and in one, the planets smash into each other, and in another, they veer apart. The time it takes for two trajectories with almost identical starting conditions to diverge by a specific amount is known as the Lyapunov time of the chaotic system. In 1989, Jacques Lascar, astronomer and research director at the National Center for Scientific Research in Paris Observatory, co-author of the new study, calculated the characteristic Lyapunov time for the planetary orbits of the inner solar system was just 5 million years. It means basically that you lose one digit every 10 million years, Lascar told Life Science. So for example, if the initial uncertainty in the position of a planet is 15 meters, 10 million years later, this uncertainty would be 150 meters. After 100 million years, a further 9 digits are lost, giving an uncertainty of 150 million kilometers, equivalent to the distance between our Earth and the Sun. That's 93 million miles. Basically, you have no idea where the planet is, said Lascar. While 100 million years may seem long, the solar system itself is over 4.5 billion years old, and the lack of dramatic events such as a planetary collision or a planet being ejected from all this chaotic motion long puzzled scientists. Lascar then looked at the problem in a different way by simulating the inner planet trajectories over the next 5 billion years, stepping from one moment to the next. He found just a 1% chance of a planetary collision. With the same approach, he calculated that this would take on average about 30 billion years for any of the planets to collide. Reining in the chaos, delving through the math, Lascar and his colleagues then identified for the first time symmetries or conserved quantities in the gravitational interactions that create a particular barrier in the chaotic wandering of the planets, Lascar said. These emergent quantities remain nearly constant and inhabit certain chaotic motions, but don't prevent them altogether, much like the raised lip of a dinner plate will inhibit food from falling off a plate, but not prevent it completely. We can thank these quantities for our solar system's apparent stability. Renu Malhotra, professor of planetary science at the University of Arizona, who was not involved in the study, highlighted how subtle the mechanisms identified in the study are. Malhotra told Live Science that it is interesting that our solar system's planetary orbits exhibit exceptionally weak chaos. In other words, Laskar and colleagues are searching for clues as to whether the number of planets in the solar system ever differed from what we currently see. For all the stability evident today, whether that has always been the case over the billions of years before life evolved remains an open question. And this is on Live Science by Anna Deming. Please leave your comments and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.